Are we all ready to go? I would like to introduce Dr. Jesco von Winheim. He is your PhD is in?
Physical chemistry.
Physical chemistry. Physical chemistry. He has an MBA out of Duke. He's an associate dean and professor of practice of innovation and entrepreneurship. He's also a serial entrepreneur. He's on his third company. He's the CEO of Xenolux Biomedical. He has a professor. He studies early stage entrepreneurship and focuses primarily on that and innovation in physical sciences. He was a co-founder of Kronos Integrated Microsystems that was acquired by JDS Uniphase, CEO and founder of Nextstream Thermal Solutions that was acquired by Layer Technologies, and he is the current CEO of Xenolux. His company develops products using light to monitor therapy and diagnose disease. As a professor of practice in entrepreneurship at Duke University School of the Environment, he works with faculty and students to identify, fund, commercialize early-stage technologies for medical, environmental, and industrial applications. So please welcome Dr. von Winheim.
Wow, thank you. Well, good. First of all, it's great to be here. And before I start, I'd like to know a little bit about you. I'm assuming, I think what I heard is PhD program here at State. Is that kind of what?
PhDs, masters, we have one or two brand new students.
Okay, let me just pop through here. Okay.
Hi, I'm Jeff Harmon. I'm a graduate student working in power electronics.
Power electronics graduate.
Devices, power electronics devices, with silicon carbide devices.
Okay, great. Yourself?
Teddy Ngusi. I'm a PhD student working in high-speed interconnect.
In
high-speed interconnect.
High-speed interconnects, okay.
I'm Nadia. I'm also a postgraduate PhD student. I'm working on wireless power transfer for cell phones.
Okay. Yes?
I'm Graham Rand. I'm starting my bachelor's degree this August, and I'm not quite sure where I'm going to go with that yet. My bachelor's degree is in physics. I'm going to take some classes to figure it out.
Can't hurt. I did my bachelor's in physics, so I enjoyed that very much. Yes?
Hi, I'm Kalpit Mehta. I'm an entrepreneur. I started my company in India a few years back, and with my friends, and then I decided to do my master's. So I'm here to do master's in control robotics and mechatronics.
Okay.
My name is David Bofat, and I'm starting an incoming master's student in power electronics.
Okay, and at the very back?
Hi, my name is Samyak, and I'm doing a master's in power electronics.
Okay, great, great. Well, you're my kind of crowd, all right? You are the people that I like to talk to, so I'm very pleased to be here. My background, as Steve has already mentioned, is similar to yours. I actually did a dual bachelor's in physics and chemistry, and then a master's and a PhD in physical chemistry. And as I was doing that, I got more and more interested in the application side of the science. And I was doing this up in Canada, and discovered, at least the university I was going to, there was just no pathway forward in terms of commercialization. Not that they didn't want to, it was just they didn't know how to help me. And I was very fortunate in that I got a NSERC grant up in Canada, which allowed me to come and do my postdoc here at State. So I was in one of the first, or maybe second buildings that they built on this campus. If you go to, I think the first three buildings and the textile building were up when I first came here. And I worked on diamond thin films with Jeff Glass, and at that time also there was a lot of let's say competition between diamond and silicon carbide as to which of those materials was really gonna win the day in electronics. And of course we know that now. Silicon carbide in some ways has done much better. I went on and one correction to what Steve was saying. I did an MBA at UNC, and actually never saw myself necessarily being part of Duke, but started working with students there about 10 years ago. At that point, we had started a company called Nextstream, and I was asked to come in and work with engineers to teach them marketing. And I can tell you right now, it is much easier to teach marketing to an engineer than engineering to a marketing person. So that's why I say this is my kind of crowd. I love to talk with you know, the better you are what you do technically, the more I like to work with teams like that. And you'll see a little bit when I talk about the startups I've done. What I'm going to talk about today is creating wealth with your brain. You know, how can you be an entrepreneur, and what are the things that you want to think about as you move forward? And in fact, I got involved in teaching. First of all, I love to teach, but I got involved in teaching because after I'd done my startups, you know, and I looked back and I thought, what's really important? I kind of felt, you know, I can almost put that into a thimble. That's how little you need to know. But when you're starting out and doing your PhD like I was, there was nobody to help me. And I like to tell people I was very, very fortunate in the mentors that I had. But I don't know if I ever had a mentor for more than 6 months. And I moved forward in sort of a Brownian motion. I had no idea what I was doing. Okay, but I ended up in a pretty good place. So I was very fortunate, and I thought, boy, I could take some of these things I've learned, and I could put them into a pretty simple kind of this is how you start a company, and that's kind of what I teach. And we'll talk about that a little bit today. I feel very, very strongly, and perhaps it's because it's my own history, that, you know, if you are technically oriented, and particularly if you go to a top-tier engineering school, you are really well positioned to become an entrepreneur. Doesn't mean you're going to become an entrepreneur, because there's other things to it, but you've got a better chance out of the starting gate than most, and that's what I'm going to talk about today. First of all, we talked about my background already. I was in fact extremely fortunate to be working with an organization called MCNC, where at that time they were a state-funded and grant-funded organization that was doing semiconductor technologies here in RTP. And they'd been developing technologies for years and years and had never started a company with it. And I came in just at the time where they felt that was really necessary to their strategy. So I had this incredible opportunity between 1997 and 1999 to start 4 companies there. One of them was Unitive. I raised the first $6 million for that. That was eventually sold to Amcor. Then we started Kronos. Kronos is an incredible story. We raised $8 million on a $17 million valuation in December of 1999. Okay, so at that point, the company was worth $25 million. We sold it 6 months later for $750 million. All right, that's about as big a home run you're going to get in your career. So we were very, very lucky with this. Incredible experience. I've written a number of case studies on it to help students learn what that's like. And then we took Nextstream was a spin out of RTI, and Nextstream we funded in 2004, and it sold in 2013. Right, so a little bit longer. Unitive took quite a long time too, and now we're doing Xenelex out of NC State, out of Duke. So this is really what I'm about. Technology, the better it is, the more complex it is, the more fun it is, the more I like it. Okay, and of course the teams that wrap around that. I'm always looking for top-tier teams because to me that's the core of really doing something great in the space. But there are challenges to doing this, and that's what I'm going to start off with talking about today. So technology challenges are timing, funding, and process, right? And I'm going to talk about all 3 of those. How can you turn these challenges into strengths as a scientist or an engineer? That's the next topic we're going to talk about. And then I've got a couple of examples here of Kronos and Xenelex that I'll take you through to give you a sense of how it works. All right. None of this are we going to get into huge detail. So hopefully this will all be pretty comfortable for you. So it's one of my favorite topics in entrepreneurship. Entrepreneurship is all about timing. And so if you ever think of starting anything up, timing is the one thing that you've got to think the most of. Where do you fit in the world? All right? And I want to start with what is often called the Gartner hype cycle. You can Google that and you'll see they came up with this picture, and they have much nicer words for it than I do. But it's a chart that looks like this. If you have an idea at some point, and especially if you're a scientist, you might have an idea before anybody ever figures out that this could be interesting. In fact, that's highly likely, right? We're going to talk about Cree in a little while, and you'll see how long it sometimes takes these ideas to get visibility. If it's a really incredible idea, it may go through a hype phase, right? And if the company does not succeed during its hype phase, it might come off of that into what eventually here is called the chasm, or the valley of death. Anybody heard of that terminology, the valley of death? Okay. The valley of death is where you no longer have people excited. You're right up here, right? You got all this excitement. They can't get enough of you, right? Now here, they're not excited anymore. And you're suffering, and you're really moving through a desert. And you might do this for many years before you may never come out of it, or you may eventually come out of it. This is an example of a hyped company during the .com era, Pets.com. Anybody know a company called Pets.com? Doesn't exist anymore, all right? They raised $60 million during this hype over the .com era. And in fact, one of the first places they spent their $60 million was an advertisement in the Super Bowl, right? The problem they ran into is they were a little ahead of their time. So they had this idea. They were kind of be like the Amazon of anything to do with pets, like a pet store online, which today everybody would say, hey, yeah, for sure, that should be easy to do, right? But at that time, they were pushing sort of the edge of technical capability, and they got so many orders they couldn't execute, all right? And they never made it past that, okay? Yeah, that's poor. Their mascot's not looking too happy there. If you make it through this phase, or you might sometimes never even get into a hype phase with your idea, okay? You might be in what I mentioned before is this chasm or valley of death. So in this area, you're really trying to convince people that you've got the next best thing. They're not very interested in it. You might be trying to get customers on board. You have trouble raising money. You're living hand to mouth. If you're young, you're probably living, back home trying to make it happen. If you're older, you might be, living out of your car. Who knows, right? That's why this is called the chasm or the valley of death. It's not a good place to be. And if you make it through that and actually create a real product that's of value, you go into, this is a classical product or company life cycle. You introduce your product, you grow, it matures, and you decline. So this is a well-known life cycle. Every product, and in fact, I believe every biological system has this kind of life cycle, right? So this is nothing special for startups. This is just the way the world works, okay? Your goal in life is to actually get there if you're doing an entrepreneurial effort. The part that I am interested in my education and also as an entrepreneur is the very beginning of this cycle, okay? Concept, seed, growth, sustaining, and exit, right? So I have some sort of concept, it works, I seed it. When I say seed it, my goal is to get seed investment for it, to grow it, probably with more investment, to show that it's sustainable, and then to exit, all right? That is the core of entrepreneurship, and that's where most entrepreneurs end up. There are some companies that are very, very fortunate, and I think Kronos is one of them, is we were in a hyped market at that time in the late 90s. Photonics, telecommunications was incredibly hyped. We happened to stumble into that, and we sold. When I say we sold at the peak, we sold the day before the NASDAQ started to drop in 2000. And the NASDAQ went through the roof, we sold, and the next day the NASDAQ started to drop and it never came back. So we got out at the very top of this, okay? But most things end up over here, all right? This concept and seed stage, my argument is really the engineering sweet spot. If you're an engineer or a scientist, you really have an incredible opportunity, more of an opportunity to build something in here than anybody else, all right? You're probably, if you're doing your PhD, you're working on some cutting edge process, idea, product, okay? Which most people, everybody else, doesn't have nearly as much chance to do, right? If you go to Fuqua or you know, to any MBA program, Masters in Business Administration program, you got lots and lots of smart people, right? But unless they're engineers, they're going to have trouble doing that, right? So to an extent, what I like to say is that technical teams are kind of a gate to entering the marketplace, at least for the type of deals I do. So you're very well positioned here, okay? Now we talked about this timeline, and I want to give you two examples. And this is going to be very pertinent, I think, particularly to you. I'm going to compare Cree to Snapchat, okay? You're familiar with Cree? I think Cree is one of the most value-adding institutions, certainly in this region, if not the U.S., if not the world, because every LED they put on the market saves an incredible amount of energy, okay? So if you think of Cree not only as a semiconductor company, but as a sustainability company, they're adding incredible value to the world, okay? But it took a long time. So the technology was developed here in the 80s, right? They launched the company in 1987 as a company. They productized in the 90s, and by the way, this was all around silicon carbide. This was around gallium nitride on silicon carbide. So they made a big shift in terms of getting from what they initially wanted to do to where they actually productized. By the way, you kind of get a sense here of valley of death, chasm, 1980, let's say 1987 to the 90s. You know, okay, how was that financed? Any thoughts? I can tell you it wasn't venture financed. Venture wouldn't touch the company. You got a lot of DARPA money. Why could they get DARPA money? Because they had technical brain trust behind it. Bob Davis out of NC State, #1, okay? Great name in materials. That's the kind of name that they had. And then, of course, his students behind it. Their lead guy, whose name escapes me right now, John Palmer. That's it. They were able to get that kind of funding. Now, they did eventually get private funding. And in fact, a very good friend of mine who recently, unfortunately, passed away, put money in this company and did exceptionally well, okay? But they couldn't get venture funding, and we'll explain why in a second, okay? So they productized. Today, they're worth, or last year, I don't know what they're worth right now, but they were worth $5 billion. That looks like a pretty interesting story. I think anybody would be like to be part of a $5 billion company. Anybody here use Snapchat? Yeah, if you're young, you use it. My kids use it. I don't use it. You know, I can hardly spell it. But let's look at Snapchat and compare that to Cree. So Snapchat was founded and productized in 2011, and in 2015 was worth $19 billion. Okay? All right, so this is a challenge that you face. If you're trying to productize, create companies in a physical science area, as opposed to, you know, the newest app, anything to do with software, which venture loves, and I'll explain why more in a second, okay? But it's definitely a big, big challenge. On the flip side, at least you can do this, okay? At least you can do this. So, if you kind of look at it, if you look at Snapchat's part of this hype kind of area. And I bet you today it's not worth $19 billion anymore. right? That's a game. It's really, I like to call it a full contact sport. If you have a company in this space, you know, you got to get in and get out fast. Try to take it public as quick as you can, or in our case, you know, where we sold the company, you want to sell it and be careful not to go on this side, right? Because once you fall on this side, it's over, right? And even companies like Groupon that went public, once the hype went away, they've had struggle at really building a real company out of that, even though they raised a lot of money when they went public, okay? Cree, on the other hand, has made it through the chasm, and they're a great company today, okay? So, let's talk a little bit about funding, and I've already given you some hints as to where I'm going with this. We're going to first talk about venture funding, right? And this is just good background. When I started out starting companies, I had no idea what venture was. And I'll say one recommendation I would give to you is don't start a company and don't know what venture is, right? You would want to go out and educate yourself. And we're going to start that educational process today, but it's not nearly enough. You want to learn a lot more about venture before you start raising money, okay? But and I'm going to give you actually data on US and Europe, and I've got data through 2014. I haven't put 2015 data in yet, okay? In 2014, in the US, $48 billion of venture investment was made, which is huge, really huge. And it's coming back from a real fall. I don't have the data here, but in 2000 and I guess it was in 2000, it was about that high, and it dropped all the way down after the telecom tech bubble burst. So it's just coming back, and this is a big number, and I think it was bigger last year. Compare that to Europe, not so big. In all of Europe, 3.6 billion euros. That's about, I don't know, $5 billion, something like that. Okay. So still, you know, in the U.S., that's a pretty good story. If you want to raise money, at least they're investing. However, let's take a closer look at seed investments. They're the most likely investment that you would go after if you had a technology at a university and wanted to spin out, right? You would get a seed investment maybe from a venture capitalist. And they're at historical lows, okay? Really, I don't have the numbers here, but this is really, so here you can see this is what happened after the telecom tech bubble burst, right? This came way down, started to come back. What happened here? Any ideas what that was?
Recession.
Yes, 2008, right? The Great Recession happened, and this came way down. Now, it might be coming back, but still, in 2014, seed investments were not high on anybody's list, okay? In Europe, there are more seed investments, but still nothing great, okay? Scale, this is very important to think about, is how much typically do VCs invest? In seed stage in the US, 3.7 million. It's not you can do a fair bit with that. I would say that, you know, if it was a semiconductor type company, yeah, it's a drop in the bucket for what you have to raise, you know, going through the whole deal, but still you can definitely start something on 3.7. In Europe, it's 0.21, so 210,000 euros. And I've given this talk in Europe, and I'm like, I don't know how you start a company on that kind of money, okay? Maybe a software company, like it's if you and two friends and you're doing software and you're, you know, again, back home with your parents or something, that might work, but I don't see that really, even these numbers aren't huge in Europe, okay? And I think that's a problem for them ultimately. It's going to drive the type of companies that they can really do. Although I'll say one more thing, in Europe there is potentially more government support, you know, for later stage type efforts. So I don't know a lot about that, but that's the only thing I could guess that would make up for this. Investment focus. So if you look in the US, software, biotech, media, and IT services make up the top 75% of investments. does not bode well for power semiconductors. Let me see, down here somewhere, maybe this? I don't know, or maybe this one, I'm not sure. In Europe, it's life sciences, communications, computer and consumer electronics, energy and environment. My point is this could be a real barrier if you're going out and thinking of raising venture money. If they're not making investments in your space, it's going to be hard to convince them. You know, venture investors like to portray themselves as the cowboys, you know, of the Wild West. They're out there, the independent guys, but honestly, they're like schools of fish. Okay, when they see an opportunity, they all go in that direction. And if you're over here and you're not part of whatever they're excited about, you're not going to get an investment. If you are over here, it's great. You know, like in Kronos. Kronos was a micro electromechanical systems company. We initially billed it as such and had a terrible time raising money. We basically got lucky in that Intel got interested in us, and that drove investment in our effort. This is and you'll see it later, we were doing 10 million in revenue when we raised money and had a tough time, okay? We then pivoted and we became an optical communications company, right? And 6 months later, we sold for $750 million. So it shows you how important it is to be in the right space, okay, if you're going to raise this kind of money, or in fact sell your company. You know, you want to be in a hot space. So this is something to think about if you ever do think about raising money, is, you know, what kind of deal do I have and what is the venture community investing in? 28% falls outside of these first four, right? Geography is an issue. So the top 75% of all investments are made in New York, Massachusetts, and California. All right? So if you're not in those three states, there's another problem. All right? So you can start to filter this through, and I'll show you the numbers for North Carolina in a second. Not a pretty story. Okay? So here's North Carolina. In 2014, our share of money was 0.7%. So 0.7% of venture investments were being made in North Carolina. I got to tell you something I'm proud about in my career. In this kind of environment, I've raised $50 million. Okay? So that's not easy to do here in North Carolina. And it's much harder, by the way, today than it was, you know, a while back. But it is tough to raise money here. I can tell you that right now. So location becomes an issue, right? And this also relates to the type of deal. If you're doing a healthcare deal, you're more likely to get an investment in North Carolina than, you know, elsewhere. Although again, healthcare has fallen out of favor, right? Used to be a big, big area for a venture. The two funds we had here locally that invested primarily in healthcare and the physical sciences was Aurora and InterSouth, and both of them do not exist anymore. They do not invest anymore, okay? So that's how much pressure we've seen in this region, so that's tough. So here's, I did some quick math for you, closing an industry energy deal in, which is kind of where I think power semiconductors might fit, okay? Well, total investment in 2014, $48 billion. Our share of it was $340 million. Industry energy, 5% of that, $17 million. If you're doing early stage, $5.6 million. If you're doing a seed stage, $250,000. That means there was probably one seed stage deal done here, statistically, in North Carolina in 2014. So these are not great numbers if you're in North Carolina. Doesn't mean, by the way, that you can't be successful. It just kind of goes back to the way I started this conversation, is inform yourself so that you don't, I see students come to me, I'm going to go out and raise venture money. Well, you know, do you know what that means, right? First of all, I can tell you from personal experience, it means a lot of travel. So of the 50 million I raised, 48 million came from outside of this region, okay? So I was in California, I was in Boston, and I was up in Washington a lot. That's where ultimately my funding came from. So, let me get back to this timing issue and the venture mismatch that you need to think through. Where does venture like to invest? First of all, they love to invest in this. Okay, if they can jump on this, they're going to do that all day long. They love the risk, okay, and they love the reward that comes from doing this. And they're really, really good at it. Right? They know exactly when to spend what money and what sort of portfolios to create to succeed here. The VCs that do this, they're the very best out there. Kleiner Perkins, Sequoia, all of these folks, they really know how to play this game. The other place they like to invest is here. This is after the valley of death, okay? When you've proven that your stuff works, right? When you have customers who are buying it. In some cases, like in Kronos, we had manufacturing agreements in our hip pocket. That's when VCs started to get interested in our deal, okay? So this is the place where VCs like to invest. And again, it's software, IT, media, and biotech right now, maybe some medical. But remember, you want to think about that when you're doing. Now the question is, what are you doing here? You know, I've never started out here. I was very lucky in Kronos that we fell in here. That was just happenstance. A lot of the stuff I work with is here, you know, so what do you do? So we're going to talk about that still. The other challenge that you face, and this kind of really comes down to what I do at Duke, is process. What is the process for commercializing your technology, right? Believe it or not, it's got a science to it, I believe, like anything else. You know, there's a certain series of things that you should do, and if you do them consistently correctly, you will eventually succeed, okay? You go out and Google startup methodology, and this is what you'll see. Okay, and certainly one of the ones that is very at top there is lean startup methodology. Anybody heard of that? It's the hot topic of how to start up a company. Basically, what it boils down to is go out and talk to a bunch of prospective customers as quickly as you can, and then make some decisions before you move forward. The problem with this is it works exceptionally well for software. You can code over the weekend, try it out. It's much harder to do when you're working with real physical science, right? Because quite often you can talk to people about your idea, but you don't have it yet. And then it takes a lot of time to create it. And yes, you can talk to customers, but until you have a prototype and get it in their hands. And then even when you get it in their hands, I'll tell you from personal experience, it can take years before you get positive feedback around your idea. So doing something quickly, iterating quickly, is possible in some types of deals, but not in all, okay? So, you know, here you are, dang, right? If you don't have a lean startup, what methodology are you going to pursue? So, what I talk about is a framework, okay? Now, in this framework, what you're really trying to juggle is this whole idea of how do I fund it? How do I move this thing through to the point where it becomes a product? And I'm not going to get into a lot of detail here, but the point really is that I want to focus on this beginning to sort of growth phase. That's really, as an entrepreneur, where I would love to succeed, because I know if I can get to that point, I can start raising venture money, and it's highly likely that I'll get through to an exit. And so I see this as kind of 6 basic steps that you need to think about. And I put every deal that comes to me, I call this a little roadmap, right? Going from concept to company building. And every deal I look at, I put it, where does it fit on here? Okay, so first step is concept validation. You have some idea, and you need to validate the science behind that idea before you can go out and start thinking about building a company. I have been in many situations where people have ideas and the concept of the science is not yet validated. Okay, even in Nextstream, we actually started with something that wasn't, although I didn't know it at the time, wasn't truly validated, right? Once you've validated the science, you need to validate the technology. And what I mean by that is, the first one can be almost theoretical. This one is real data, charts and graphs that show that this stuff really, really works, right, under various conditions. Then there's two steps here, prototyping and market validation, that kind of come almost hand in hand, all right? You take your stuff and you make something out of it that you can hand to other people and that they can work with. And in particular, that you can hand to customers and they can look at it and test it and try it, okay? And it may not be, the perfect final product. In fact, it usually isn't. But if it's cool enough and it's exciting enough, you can put it into the hands of experts, customers, and so on. And while you're doing that, and a little bit before it, you're also validating the market. For the most part, to me, market validation means getting customers who pay for your stuff. Okay, that's the ultimate market validation. But you're also looking at market studies. You're really trying to figure out how big can this be. All of those things are part of market validation. If you make it through there, you go into a product development phase and finally a company building phase. You can start a company, and people do, anywhere along here. My personal preference is, not to start at least until you have a clear product pathway. You have a customer that says, yes, this is the product I want, this is where we want to go with it. And along with that, there's sort of three areas that I think you want to educate yourself. The very first is, how do you identify a good opportunity? And I see this, I teach 100 to 150 graduate students a year at Duke, right? And the biggest problem is they have no idea if something's good or it's bad, right? And certainly if you're working in the lab, you want to not only train yourself in the science, but if you're interested in entrepreneurship, train yourself to learn what a good business opportunity is and what a not so good one is. But you're not going to do that in a vacuum. You have to get educated by folks who can kind of help you with that. The next one is market engagement. I get the most excitement from my students when we talk about how I engage customers in my companies. This is a sales process. We don't teach sales very well in universities, okay? So how do you go out and actually sell to customers? How do you find that first customer? How do you engage them? That's what I mean by market engagement. And again, that's a skill set that you can teach. And then finally, and this is more mechanical or mechanistic, is startup operations. How do you actually start a company? What kind of company should it be? A C Corp, an S Corp, an LLC? What do you have to do in terms of intellectual property protection? When you raise money, what is the dilution that's going to happen to your ownership in the company? These are all things that are very important to learn about, before you go off and randomly start something up. So those are three skill sets, that you want to, if you ever want to start a company, you sure want to start by learning those skill sets. The good news for you, for engineers and scientists, is you're in an environment where this stuff is what you do every day. Okay? So you have a head start on everybody else. And what's cool about this, you see I've got some timelines down here. If you're doing your PhD or a postdoc or a master's and maybe going to a PhD, guess what? You got lots of time to do this, right? Universities are fantastic for spending time doing this. In fact, they're built for it, all right? So you have a head start, and you are in the perfect environment to kind of do a lot of this, right? What you want to learn is how to do this part. And then again, ask yourself the question, how does it get funded? Well, the great news in America is we have NSF, NIH, DOE funding, STTR, SBIR. There's foundations, endowments, crowdfunding. I use every single one of these, okay, on the startups I work on today. So Xenolux in total has raised about $15 million of grant funding in one way, shape, or form, of which $5 million has gone to the company and the rest has gone to Duke. Right? But that's how that company has been seed funded, no venture money in it. And it's just because we're too early. If you think of the timeline, we're too early for venture, so we figured out another way, right? And especially the STTR and SBIR, particularly if you're a postdoc in a university, if you have a really well-known faculty that you're working with, these are much easier for you to get. Okay, so this is an area, and you can raise millions of dollars through this, millions, and it's literally free money, right? If you take money from a venture capitalist, they're going to have a piece of your company. When you get an STTR and SBIR, the government doesn't want any of your company, so it's called non-dilutive funding. And I'm going to show you in Kronos how important that was, right? So focus on teaching yourself kind of these two things. How do I identify an opportunity, and how do I engage the market? If you do those two things, you have a chance of becoming a good entrepreneur, right? Because that's what's usually missing in engineering teams. And in fact, my entire career has been based on my ability to do this, because I always work with great technical teams that can do the other things really well, okay? The other thing I do is I focus on 5 metrics: team, technology, market, customer or revenue available, and ability to execute. So I look at every deal with respect to those metrics, and I want to make sure I'm working with one of the top teams in the world. I want to make sure it's a unique and protectable technology. I want to make sure that at some point I can envision it going into a large market, okay? First and foremost, if I really get serious about this, I want to go out and raise money, I'm going to have a customer, right? I've never raised money in a company without having a customer. In fact, I've never really started a serious effort in a company without having some sort of customer generating revenue. And then ultimately, every deal is predicated on the ability to execute. And this is again where scientists and engineers and universities have an incredible advantage. You have the facilities and the capability to build stuff, right? That, if I go out, let's say Nextstream, when we spun Nextstream out of RTI, I had to raise $8 million just to get started, okay? You don't need to do that. You've got a lab, you've got facilities, you've got all sorts of things. You can build stuff now, right? And if you can get someone interested in what you're doing, you can probably deliver it to them. So that's very, very important. So what we do is we have a program. This is the program I teach at Duke, and it's now actually also being taught in, or will be taught in Amsterdam by the Amsterdam Health Technology Institute, where we go through this process and we focus on this, and actually also company startup operations. So if you're interested in learning more and you want to somehow participate or learn about it, just come over to me and I'd be happy to connect you in with that. So you can do a lot of learning. In fact, when we finish the program for ATI, this is going to be online, and you can kind of go through it yourself if you want. Okay? The last thing I want to talk about is 2 brief case studies. The first one of Kronos, which really, really worked. Okay, and why did this work? A couple of things. First of all, this here is grant funding for Kronos, the green. All right. The woman who founded it, Karen Marcus, was brilliant CTO, and she was also brilliant at getting grant money in through DARPA. This is about $22 million. Okay. She would never, ever have raised that from the venture community. At any point, she could have tried it here, here, here. We raised money here in 1999 when we were generating $10 million in revenue, okay? The other thing that got the venture group started to get excited about is you can see here the commercial contracts blowing up, really becoming significant in 1999. And then this MUMP service work, by the way, is also commercial. So you can see that whereas here the grant funding dominated, here it was almost half, well, a little bit more than half commercial, okay? And of course that gets people excited. But my other point is, look at this, from day one, money was being generated. Remember that metric, customer/revenue? They knew what they were doing. They generated dollars from day one, right? A lot of this was around service contracts. They had a capability to do microelectromechanical systems, and they sold it to people, including the government. And so they were able to generate these kinds of contracts from day one, okay? This is Zenelux, just still a long time. By the way, look at the timeline, right? Started in 1993, funded during, one of the best venture environments that we've ever had. So it's still here. Took 6 years just to get started, right? Zenelux has been bumping along, but really started most around, I'd say, 2009. Again, very focused on grant funding, but you can also see that we're trying to sell commercial systems, okay? So our whole focus is getting customers on board, right? So very similar story that way. So let me just finish with takeaways. It's tough, okay? You want to commercialize, it's a full contact sport. And it takes time, it takes intellectual capital. You really have to keep that in mind as you go off to do it. And VCs, they want immediate returns, and even if you have something really, really good, venture money is hard to get, okay? Especially here in North Carolina. But you have a lot of advantages. You've got access to IP, access to grant funding. You have the patience and the right kind of environment to be able to go off and do this, right? So if you want to focus on something, first of all, I would say the top of your list of things to do in the lab is create real prototypes that you can hand to customers, okay? That alone is going to help you in your career no matter what you do. Market engagement, rarely done within the universities, but boy, I can't tell you how exciting it is to go out and have real customers using your products and actually giving you feedback and making things better with their feedback. I mentor a gentleman who I had breakfast with this morning, and he doesn't have a technical company. He's got an online sales company, but he has the concept, and he just, in the last 3 months, went out and talked to 40 potential customers. And he came back and he said, I can't tell you how invigorating it is to talk to customers. And he's so right. It really will change your world once you get that feedback, and we don't do enough of that at universities. And then remember the metrics: team, technology, market, customer, ability to execute. How does your deal kind of fare in all of those areas? All right? And that's it. Thank you. I hope I covered the topics that you wanted, and I'm certainly happy to answer some questions.
I said two things. One is I was listening, it's been a few years ago, I was on eCorner at Stanford, and Guy Kawasaki was giving a talk, and he said, you're, the odds of being on a golf course in Florida during a lightning storm holding up a golf club, you have a higher probability of getting zapped than you would getting venture capital. Or it was the other way around, some dry place, I'm sorry. some dry place. Yeah, like in Arizona.
Right.
Getting struck by lightning and getting venture capital. And I read in Inc. 500 several years ago where they talk about all the companies that were part of the Inc. 500 that year. And it was something like 2% actually taken venture capital.
Yeah.
All the rest was done through mortgages and families, friends, and getting customers
and we really have an advantage through the grant process here in the U.S. More and more money is being spent on, and even, by the way, within the universities. So there are programs called the Partnership for Innovation, where you have to really focus more on commercialization of the technology. Those are funds that are granted to the universities, not to startups, and they are very much like the SBIR program. So you can get $200K and you can get $1 million, right?
What happens now? I mean, I don't mean to grab it from here, but I mean, for me, when I had my company, it cost from the day we said go to the day that the chip arrived back, from Taiwan and stuck in the tester we had, it was $25 million. Today, that same thing is $50 million. Now, you just told me that our venture funds have just closed. So, I mean, what happens with people like this who are working with these new special types of systems? Where are you going to go?
Well, A, you get very, very creative. B, you can still do if you're, through ARPA-E and others, you can still do this, I think. But that's, if you can't do this, I think it's, there's no one on earth is going to invest in a new semiconductor technology that you haven't proven. Okay, now you get it to the point where you can prove it works, and you've got 5 customers lined up, nodding their heads saying it works. Then you have a chance to go out and raise money. So the thing to think about is, okay, this is our world. Let's not dream about getting venture money for this brand new idea. Let's realize that our environment is such that we have to figure out other creative ways to do that.
And that's how we evaluate what is a good idea and what is a bad idea.
So I'll tell you, I actually have a case study for Kronos. So in Kronos, really interesting, we started with a micro relay, which was the wrong product. And but we were very focused on these metrics, or I was, okay? And I was bound and determined to get a customer, get a customer or die. That was kind of my mindset. And in doing so, we did get a customer, and that was Nortel. And Nortel spent about 18 months testing the micro relay and proving to themselves it was never going to work for their application. But in doing so, they decided we were a great group to work with, and they were just getting into photonics, microelectromechanical photonics, so micro switches and attenuators. And we pivoted over there, and that's why our value went, like, in such a short period of time from nothing to what it was, because we changed based on what the customer said.
So you start and then you can change your basic thing based on the customer demand.
Sure. Yeah. And this is, by the way, also why ability to execute is so important. So, for example, here at NC State, let's say you can build a certain chip in some way, shape, or form that you think is the next best thing, right? Go out and find customers for it. And if you may have something, it can't be garbage, right? Because then nobody will look at it. But if it's sexy, people are going to want to look at it. Everybody loves a new baby, right? In looking at it, I've never had a situation where customers looked at a product or a prototype that we built and said, that's it, I want it. Never happens. What always happens is they look at it and they're like, yeah, I like this piece of it, but really I'd like it to do this. And this is where you would have to come back into the lab here and say, okay, can we build what they want, right? We have a deal we're working right now, or technology. It's a new cloud computing technology where we're doing exactly that. We have a really cool capability, and we've actually used it to build a really neat cloud computing capability around the world. It's called ExoGenie. But then when we've taken it to the marketplace, to companies like Dell and Cisco and big companies, they're like, that's interesting, but can you build this? And that's where we exactly are right now. We're asking ourselves, can we build this for them? Because they're telling us, if you can build this, I've got $1 million for you, right off the bat. If you tell me you can build this, I've got $1 million for you, which is a great way to fund, right? B, where there's $1 million in one company, there's probably millions in other companies also. So you start to get interested, right? That's what you have to do with the technologies you're working on here. And it's never been any different in any startup I've done. Yes?
Thinking about your Kronos example, if you're at the point where you're pulling in $10 million a year, why would you accept venture capital at that point and give up some of your autonomy?
Okay. Well, we were pulling in $10 million and we were spending $10 million. Okay, this is especially look at this. This growth rate is very, very hard to fund. If you think about just the fact that every new sale that you make, you have to hire new people, you have to buy materials to go fulfill that. So you're investing just to fill the order that's going to take you 10 weeks to deliver. So the cash that you need in a growing company is tremendous. So we figured out we needed at least, I think initially we said we needed at least $6 million to continue to grow like this.
What were your, got any horror stories?
Horror stories.
Yeah. You know.
Yeah, I would say that horror stories are usually around chutzpah, and I would say it is not. It's in those instances where I've not been rigorous here that I've run into horror stories. You know, so for example, in Nextstream, we thought we had validated the technology, and it turned out we hadn't. You know, and that's not blame I would put on anybody. We had a really capable team that looked at this for about a year, and we thought we'd figured it out. And then we raised money and went out there, and we realized there were pieces that were missing. You know, it's kind of, sometimes you don't know what you don't know. And so in Nextstream, that really caused us a headache. I would say the other horror story in Nextstream was we were, what it turned out, we were a one product company. Okay, and I was convinced. So what did Nextstream do? Nextstream built the world's smallest refrigerator. Okay, we basically built a cooler that was the size of a piece of confetti, and we could make the difference in temperature between the top side and the bottom side as high as 60 degrees, and the distance between them was about 20 microns. Okay, so you can imagine the kind of gradients we could produce, and these devices could pump a huge amount of heat, right? And we made a case to Intel. Remember the customer piece here. We made a case to Intel that we could cool hotspots on their microprocessors. At that time, Intel had just designed a chip called the Swaharo. And if you look back, the Swaharo was canceled after about $200 million of investment, because when they switched it on, hotspots formed and melted the silicon. And you can calculate the kind of heat flux you need, but it's like the heat coming off the surface of the sun, okay? And these were very tiny hotspots that you could do all the calculations. If you could put a little Band-Aid underneath, cooler, kind of like, you know, putting a air conditioner into the corner, into a window on a room, you could pump the heat out of that entire room using that one small air conditioner in the corner. That's the case we made to Intel, and they bought into it, and that's how we raised all our money. We actually demonstrated to Intel technically that we could cool up to 15 degrees, which was huge. Every 5 degrees is a new generation in microprocessor. So that's the kind of value that our technology could add, which is also why we raised money. The problem is we couldn't manufacture to save our life. So we couldn't meet the needs we could meet the technical needs, but we couldn't meet the manufacturing needs of Intel. And Intel, therefore, didn't accept our technology. What did they do instead? They went to quad core, spread everything out. Okay? That's why our computers are not getting faster anymore, right? So they went to quad core, and we were left, you know, sort of in the dust. And my belief, and this is where the chutzpah comes in, I just figured, hey, we'll find this is cool stuff. We'll find something else to do with it. Well, it turns out we couldn't find that level of value generation in any other application. And so that became a real struggle within Nextstream. So that's a long horror story, but you know, we ultimately sold the company reasonably. You know, we sold it to Laird, but not with the kind of win that we would have gotten if we could have, you know, solved the problem like we were trying to solve for Intel.
When a company comes to you and says, we have $1 million for you if you can build this, how do you resist the temptation to say, of course we can do that?
Well, so even though I have a science background, I'm a marketing guy, and that's exactly what I do tell them. Okay. Then I go back and I arm wrestle with the engineering team. I will say if I accept that I can lose that arm wrestle, and then I'll go back to the customer and say we can't do it. I've lost that fight many times. On the flip side, I also know the engineers are always going to say, oh, we can never do this. Okay, so you have to end up somewhere in between where there is some risk, but we feel we can do it, right? But I would never ever let the customer know that. I would always say, hell yeah, we will do that. Okay, and then. In fact, we're going to have a meeting on that, I think, later this week to see if, in fact, we can do it. We'll find out.
Just to give people kind of an idea, to get for children, what's the work-life balance that you've been able to strike, and have there been times where it's been
So while I was doing up till Nextstream, until I left Nextstream, my family didn't see me, and I would go with them on vacations, and then I would be working on vacations, and everybody knew, this is just what it's like, and in the terms of balance, I think if you talk to my kids, and I hope they would say the same thing. By the way, they all go to school here, so I'm a huge state fan. So my son Tusso graduated from material science here. Actually did a startup called Undercover Colors out of state. And then my daughter is doing her 4th year in material science, and my second daughter is about to start chemistry and textiles. So we're all huge fans of state. I think they would tell you that it was just, the lifestyle was the startup. Okay, my kids learned more by osmosis about starting up companies than, I'm going to learn in my lifetime, because they just kind of lived it. Wherever we went, I was on the phone, I was working, but we did things together, so that's how I tried to manage it. Now it's much different, right? Now that I'm at Duke, and I'm still working incredibly hard, but nothing like when I was starting up companies. It was just all consuming. Right? Especially Nextstream, I spent 5 years raising money, so I was on the road, constantly. I raised money through the downturn, through the Great Recession. Very, very few companies. I think in this area we may have been the only company that raised money through the downturn. So very tough, but it's just you tried to make your family part of it.
What is it about North Carolina that makes it so hard to raise capital?
I think our culture is relatively conservative, historically very conservative. If you look so we had, what I thought, 2 really good venture groups here, Aurora and Inner South. And if you look at their idea of a win was always invest some money and sell it, at some reasonable multiple, right? You go to the West Coast and they're looking for, I want home run, billion-dollar company, I want to take it public, and that model that we had here of investment was okay during the good times, but it didn't work, during the bad times, which is why we lost both those investors. We're very sciencey, right? With the universities, there's a tendency to focus way too much on the science and not enough on the commercialization execution. Although that's getting better, I think all the universities are getting much more in tune, and as we do that, we have a much more vibrant entrepreneurial culture today than when I was starting companies, but we have less money, so maybe the money will eventually follow and come back.
Any other questions? Thank you so
Cool.
very much.
Hey, thank you.